Hello Britons and Brunettes, my name is Danny S. This is a special request video to the YouTube user Desert Phil.
Good morning, Danny S. That's right, I'm drinking sour cream for breakfast. It's an American thing. Actually, it's icy cold cola for breakfast. That's also an American thing. And I'm kind of looking at the donuts over there. Maybe I'll have a couple donuts for breakfast. That's also an American thing. It's 9 degrees American outside at the moment, and that's negative 13 centigrade, and I'm having Coca-Cola for breakfast. Fucking Americans.
You're always talking about magnet motors and how they probably can't work.
There is no probably cannot work. If you're talking about a magnetic motor that does not have a source of energy coming into it, then there's no probability at all. It cannot work. If you have a magnet motor with a source of energy, such as electricity, then of course they can and do work. Our very fundamental basis of industrialized, mechanicalized society is predicated on magnet motors running off electricity.
So I'm not interested in magnet motor. What I want is a motor that can spin at high speeds but with low power.
In your video, you didn't specify what it is you want the motor to drive, what the load will be on that motor. You can buy right off the shelf many hundreds of different electric motors that are very high revolutions per minute that consume very little energy. But without knowing the load that you're going to put on that motor, nobody can tell you how to do that. No matter how much, no matter how fast your motor is, as soon as you put a load on that, it's going to consume more energy. It's going to draw more energy. So to answer your question, we need to know the load on the motor, which I can't answer because you didn't specify.
And I've seen a Bedini motor do this, and I thought...
Yes, indeed. The Bedini motor will go very high revolutions with very little electricity. But they do that without any load on them. I assume that you have a device that you want a motor to drive. As soon as you do that, the revolutions per minute is going to drop, and the current that it is drawing is going to increase. Like I said, without knowing the load that you plan on putting on a motor, I can't answer your question.
I've also seen a company called Stone who produced the Orbo.
Actually, we have to be clear on that also. Stone has not produced the Orbo. They never will. It is fundamentally impossible. What they claim that they are going to do cannot be done. It would violate the very laws that make the universe function. In my opinion, it is a clear case of investment fraud. This business is selling stocks to invest in their business that would create a device that is fundamentally impossible to create. And in my opinion, the bastards know that.
Recreate this. Now they're claiming it's free energy.
Yes, and in my opinion, they know damn well that it's not.
I don't care about free energy. All I want is a low power motor with a high speed.
And like I mentioned, there are hundreds and hundreds freely available. You can just buy them anywhere. General Electric sells them. What you need to know is the load that is going on your motor. Before you specify that, nobody can answer your questions.
I know it seems a bit stupid, but you know, just bear with me.
None of your questions are stupid. The height of stupidity is to assume something that is untrue and then base your behavior on that. Asking questions is never stupid.
I want it for a project that I'm working on. Unfortunately, I need a few other parts, and I'm not really willing to disclose what the project is just yet. However, after seeing all your videos, I am interested in your professional opinion of how that could be done.
By profession, I'm a cowboy. I take care of cattle and horses and goats and chickens and cats and dogs. Professional opinion, On electric motors, I haven't got one.
You seem to know a lot about it. You seem to be, how should I say, up to date with all the equations and exactly what's going on. So I'd like your insight, really, if you know what I could use.
Before anybody can answer your question, you need to know the load that you are going to put on the motor. Like I said twice already, before you determine what mechanical force is required to drive whatever it is your project is going to be driven by that motor, nobody can answer your question.
Obviously, I was looking at a Bedini motor because that seems to get a lot of what do you call it? A lot of speed.
Yes, if all you want is a motor that spins with no load on it, it does no work, you don't want it to do anything but spin, then the Bedini motor will go at high revolutions per minute, draw very little current. As soon as you put a load on it, as soon as you attach something to that motor, revolution per minute is going to plummet and it's going to pull a whole lot more current. Like I said 3 times already, it depends on what load you're going to put on the motor.
For the low power, I mean, I've seen it with using just a 3-volt battery.
Of course, when you're talking power, you're not talking volts, you're talking watts. And if you're talking about how much electromotive force to apply to another system over time, you're talking joules, watts per second. The Bedini motor is very inefficient. As soon as you put a load on it, the energy efficiency just plummets. You can buy hundreds and hundreds of far more efficient electric motors out there right off the shelf. Like I mentioned, General Electric, for example.
For like 12,000 mph.
You can buy a 12,000 revolution per minute motor that runs off of 1.5 volts for $3. It depends, once again, what it is you are trying to drive with the motor. I just did a Google search. I found hundreds of electric motors that go 12,000 revolutions per minute and higher. Very inexpensive to buy. Anywhere from driving little tiny cars, little toy cars, all the way up to driving passenger vehicles. 12,000 revolutions per minute, all the way up to 48,000 revolutions per minute. It depends, for the 5th time I guess it is. What are you trying to drive? What is the load that you plan on putting on the motor?
So, yeah, is it possible? I'll send you a bunch of links as well for all of these and the store in itself. I just want to know, are these things real, and could they be recreated? I know you probably say no, but if you do, could I create a motor that would do high speeds for low power like in the videos?
The answer is yes. Anybody with average or higher intelligence can build a very high revolution per minute electric motor that draws very little current, very little power, very few watts if you prefer. This is not a problem. This is not impossible. It's done all the time. You can build a 12,000 revolution per minute electric motor that draws very little current, very little power, and much higher if you get your bearings right, and if you wrap your field windings correctly, if you get your commutator brushless, reduce friction, you can get a motor going 20,000, 30,000 revolutions per minute and draw very little current. Once again, if you put a load on it, of course, the revolution per minute is going to plummet and the current that it's going to draw will increase.
I'm not interested in creating free energy. I just want to use a small amount of voltage to create a large amount of speed. That's pretty much it. Thanks for your time. Danny S out.
I'm not happy with what I have told you because I didn't give you an example, and you might be asking, Desert File, what the fuck are you talking about? What do you mean load going on my motor? I'm going to give you an example, and it's from the Shenzhen Dongshun Motor Company in mainland China, and it is a typical little motor that runs little cars and little boats, toy boats and stuff. And I'm going to look at one of their motors. It is a high revolution per minute, very low current drawing motor, and I'm going to give you an example. This is a motor that can run anywhere from 1 volt to 5 volts. The nominal voltage is 3 volts. And with no load on it, with just the motor running, with nothing attached to it except the battery, it'll go 18,500 revolutions per minute. And the current that it is going to draw is only 0.05 amps. Very low current going into the motor. As soon as you put a load on it, the torque that it is going to apply to whatever it is you want driven, your revolutions per minute are going to drop, and the current that it is going to draw is going to increase. You put torque, I guess that's grams per centimeter. If you put 12 grams per centimeter on this motor, your revolution per minute are going to drop from 18,500 to 16,500. The current is going to go from 0.05 amps to 0.28 amps. If you put a heavier load on that, such as you go from 12 grams per centimeter to 30 grams per centimeter, that's newtons that you're putting on there. Mass times the distance that you're accelerating it. You go from 12 to 30, your amps, the current, the power that is going to draw will increase to 0.7 amps.